This video we're going to be talking about sketching graphs of polynomial functions. Okay, so if you were to graph these three in your calculator, go ahead and try sketching what the graphs would look like. Go ahead and pause the video, and then I'm going to go ahead and sketch them. Okay, so this is what endgame your graph should look like. We have two parabolas, and then we have a cubic function. So how are they different and how are they the same? So I've got my two parabolas here, and then I've got a cubic, so that's kind of how they're different. The same, I've got two parabolas. The difference between the two parabolas is the first one has two x-intercepts, the other one has one x-intercept. My cubic has three x-intercepts. So just a couple of the differences and things that are the same between them. How does the graph from number one best match this picture? Okay, it kind of looks like it has some U's in it. It also has S's in it. So actually, if I go through this point, it is always going to be an odd power. So I could do this one to the first power. Anytime my exponent is odd, it means I am going through the point. Anytime it is even, like this one here, or anytime it touches and goes away, it's going to have to be an even exponent, so squared. And then we also have the 0 over here, which is going through it, so it needs to be an odd. So answering the next question, an example, this x minus 0 could just represent x. Okay, the reason that I'm doing minus 2 and a minus 3 is because if I do my ZPP property to find the actual roots, if I take this, set it equal to 0, set this one equal to 0, and set this one equal to 0 and solve them, I would get 3, I would get 2, and I would get 0, which is where they cross at. So you kind of have to have the opposite when you're making the equation. Okay, so anytime you touch and go away, so my touch and go away, it needs to be an even exponent, so that's why I did the squared. If it goes through, it needs to be an odd exponent. So that's a generic equation for that picture if we were trying to make one. Okay, using a graphing calculator to match the following functions, make a table of points and complete the following, graph it. Okay, so if you type that in your graphing calculator, you would be crossing your x-axis at 2 and -5. So the y values would be 0. So at -5 and 2, your graph should look something like this. Okay, it is an even at that 5, so you have to touch it and go away from it, and then you have to, this is an odd exponent, so you have to make sure you're going through it. Okay, my next one here, I know I'm going to be crossing at these spots here, so -2, 2, and 3. So -2, 2, and 3, and that's because I'm doing my ZPP property. If I set this equal to 0 and solved it, I would get x equals 2. If I solve this, I'd get -2. If I solve that, I would get +3. Okay, and then all of them have the exponent of 1, so I should be going through all of them. So that's what my graph should look like if I was typing it in my graphing calculator. Okay, this one's a little different because it's not fully factored. So you type in your graphing calculator, you will see it crosses at -5, 0, 1, and 4. So all the y values will be 0. So -5, 0, 1, and 4. Okay, and all of them we are going through. So if we factored that, we would get those zeros. They'd all have odd exponents. Okay, my next one, it looks like we're going to be crossing at -3, -1, 1, and 5. So -3, -1, 1, and 5. And this one is the only one that touches and goes away. So I touch it, go away, and I have to go through all the rest of them because they're all exponents of 1. They're all odd. Okay, my next one here, if I type them in, I'm going to cross at 0 and -4. And both of them, we have an odd exponent here. That's to the first power, so he will also be odd. So that means I go through it. There's a little hump right there. And I go through that should be going through the 0. Okay, my next one here, I'm at 3, -3, and 0. So -3, 0, and 3. and it should look like this. Okay, I'm going to explain in the next lesson on why. So I'll be talking about the end behavior and how we know which arrows are going which way in the next lesson. Okay, so what can you predict from looking at the equations of the polynomials in regards to its graph? You can get it zeros if it's fully factored. Eventually we'll be able to get whether it is increasing or decreasing on which side. The most useful form when looking at it to get it zeros are going to be the factored.